Back to the first year organic chemistry. We were studying the basic concepts. In that one, now let us go for the electronic reaction intermediates. Reaction intermediates. Reaction intermediates. And electronic effects. So this is the topic which actually explains the site of the organic reaction that is taking place, electronic effects. Now, before going for the reaction intermediates and electronic effects, first let us consider the bond cleavage. Bond cleavage. That means when the reaction takes place in an organic reaction, there is a breaking of the bond and a reformation of the bond. So how that bond breaks up, that we can explain by considering two methods. One method is by this homolytic. This is also called as the symmetric. And the second one is heterolytic. Heterolytic, that is unsymmetric. Now when you consider this homolytic, generally when the bond is cleaved between the two atoms which are having almost equal electronegativity, then such a bond is cleaved so that each atom will get one electron. Suppose you consider this carbon bond. When you consider this carbon-carbon bond, suppose this is cleaved during this reaction in such a way that each of these electrons will go to a carbon atom. So that it is cleaved so that each species will be carrying a positive charge. Suppose I have this carbon and X group. If this is cleaved in such a way that each atom will get one electron, homolytic, then we get this species with one electron on the carbon atom and one electron on the X group. So this homolytic cleavage with equal distribution or symmetric distribution of the electron will give rise to the intermediates which are called as the free radicals. Free radicals. So when a bond is cleaved with equal distribution of electrons, it is called homolytic bond cleavage. Homolytic bond cleavage. So this homolytic bond cleavage will always give rise to the intermediates which are called as the free radicals. Now when you consider this bond between the carbon and some other group, suppose this bond is cleaved in a heterolytic manner. Here X should not be taken as a halogen always. Any group. Suppose this X group is more electronegative, then both these electrons will go to this X group. Then we get this carbon atom carrying the positive charge and X group carrying the negative charge. Suppose this X group is less electronegative than the carbon atom, then we have this both these electrons going to this carbon atom, so that carbon will get a negative charge and X group will get the positive charge. So this species with the carbon carrying the positive charge is called as the carbocation. And this species with carbon carrying the negative charge is called as the carbon or carbon anion. So heterolytic bond cleavage takes place with the unequal distribution of the electrons, so that either the positive charge on the carbon or negative charge on the carbon will be produced along with the other ion. So intermediates produced are always the ions. when the heterolytic bond cleavage takes place. When bond is cleaved with unequal distribution of the electrons, it is called heterolytic bond cleavage. We can just write the definition. So that is about the bond cleavage. Now let us consider one more small topic, that is attacking reagents. Attacking reagents. There are actually three types of attacking reagents that we come across in the organic reaction. One attacking reagent is actually this free radical. Free radical. We have already seen what is actually a free radical. Whenever there is a homolytic bond cleavage with equal distribution of the electrons, the intermediates will carry the unpaired electrons. When unpaired electrons are present, they are named as the free radicals. For example, during the chlorination of the methane, when we consider this chlorine exposed to sunlight, it gives rise to chlorine free radicals. Similarly, when you take this methane, CH4, when this chlorine free radical attacks this methane, it gives rise to methyl free radical plus HCl. So this is actually the mechanism that is involved in the chlorination of the methane. This HNO stands for the sunlight. So these free radicals are actually paramagnetic. Paramagnetic. Because of the unpaired electron, they are attracted by the magnetic field. That's why they are named as the paramagnetic in nature. More about the details of these free radicals we will study when we consider this reaction intermediates. These are only attacking reagents what we have mentioned. When any species carries the unpaired electron, it is called as a free radical. The second one that we study is electrophiles. Electrophiles, these are the electron deficient reagents. Electron deficient reagents may carry positive charge also. May carry positive charge which attack electron rich position is called an electrophile. So either they carry positive charges or there may be electron deficiency also. For example, those with positive charges, we can give the examples of H plus, H3O plus, Cl plus, Br plus, nitronium ion NO2 plus. When we consider the aromatic substitution reactions, all these positively charged reagents will be the intermediates. This NO plus, nitrosonium ion. Similarly, the neutral reagents which behave as the electrophiles, BF3, boron trifluoride has got boron electron deficient. It has only 6 electrons in the valence shell. Similarly, we have this AlCl3, aluminium chloride. Similarly, FeCl3, sulfur trioxide. In this sulfur trioxide, oxygen will be more electronegative, that's why it causes the electron deficiency on the sulfur atom. Again, there are 6 electrons only. Similarly, SnCl4, etc. The next, nucleophiles. These are the reagents. These are electron rich reagents may carry negative charge. And attack electron deficient position. For example, we can write the negatively charged reagents. O O minus oxide ion. Similarly, H minus ion, Cl minus ion, Br minus ion, I minus, OH minus, Cn minus. Similarly, R alkoxide ion, RO minus, RO, RCOO minus. It is carboxylate ion. The neutral reagents we can write neutral reagents which behave as the nucleophiles. It is H2O, H2O with pair of electrons. Similarly, ROH, oxygen carrying the lone pair of electron. Similarly, ethers, where oxygen again carries the lone pair of electrons. Similarly, ammonia, amine, primary amine, RNH2, secondary amine R2NH. Because of the lone pair of electrons on the nitrogen atom, they behave like the nucleophiles. Similarly, the tertiary amine R3N. So these are the various examples of the nucleophiles which do not carry any charge, but they are electron rich reagents. Because of the presence of one or more pair of electrons, they behave like the nucleophiles. So this is about one topic, that is the bond cleavage as well as the attacking reagents. In the next video, we will consider the reaction intermediates and electronic effects. Actually, we will start with the electronic effects. Thank you.